Flashing across California desert skies, the airplanes you see here are writing new chapters in the story of man-made flight. There she goes.
This is my first opportunity to greet you as Deputy Administrator of the National Aeronautics and Space Administration.
Together, you and I must make our new agency
the most unusual place.
An organization that can challenge conventional wisdom.
We can engineer anything we can write the requirements for.
We're going to make your idea work. This particular idea is quite disruptive.
A typical flight, of course, starts under the wing of the B-52 mothership.
This sleek, high-speed machine would have made Rube Goldberg proud.
The manner in which we fly re-entry from space on the space shuttle was pioneered on the X-15.
The X-31 pretty much wrote the book on thrust vectoring, along with its sister program, the F-18 HAR.
An observation of an occultation is one of the more challenging missions that Sophia can do.
Right now, we are looking at the dawn of a new era of aviation.
Hic deficit orbis. Here ends the world.
Do satellites have practical uses?
You could maintain continuous transmission of telephone calls.
A chain of sister satellites will closely link all parts of the globe.
Several of them can report continuously on worldwide weather conditions. Here in outer space is a natural vacuum for scientific experiments.
It is the mountaintop and the ridgeline of the future.
The high ground of military capability now.
Will at first timidly penetrate beyond the limits of the atmosphere, then we'll conquer all the space around the sun.
Men have been dropped out of high-flying bombers and rocket aircraft to probe extremely high altitudes.
Moving away from Earth into the borders of space.
Beyond the aerodynamically effective atmosphere.
At extremely high altitudes, the conventional aerodynamic control surfaces are not sufficiently responsive for complete flight control.
The answer?
Reaction jets.
What it would be to fly a vehicle that didn't have atmosphere. Everything that anyone subsequently used for reaction control systems in space derives from the work they did out here.
From the flying laboratories of the X-2 and 3, there evolved a new kind of aircraft capable of flying into space, the X-15.
The epic mission for which it was designed, to skim the upper limits of the world's blanket of air, higher than man has ever ventured before, and then to handle like a conventional plane in landing.
A rocket, airplane, and spacecraft in one.
Fundamental data applicable to the problems of manned hypersonic and space vehicles can be obtained in full-scale flight, providing basic information in advance of design needs for future space missions.
First thing you had to do was get the engine lit. And then all of a sudden, here I was sitting there with my head back and I couldn't move it.
60,000 pounds of thrust in a 30,000-pound airplane. When you lit that engine, why, you could tell you were hauling the mail.
Yes, pilots aren't supposed to say they're afraid, but I was impressed.
During the climb, we were controlling the airplane with a right-hand side stick controller. And as we exited the atmosphere, we transitioned to a left-hand controller and flew the airplane with the reaction control.
What is being done to protect man in this heretofore unknown environment?
We were looking at what it would do to the pilot, what it would do to the airplane. All of those things were unknowns.
This multi-layer suit is complete with air conditioning, pressurization, oxygen supply. It gives the comfort and mobility needed to control an airplane or a spacecraft.
Re-entry into the Earth's atmosphere poses another set of problems.
Air friction will heat parts of the plane to a red glow, 1,200 degrees Fahrenheit.
We coast the remaining 200 miles back to Edwards for a powerless landing at the dry lake.
The X-15 pioneered re-entry from space to an aerodynamically controlled landing. The flight program proved that winged Earth exit and re-entry are well within the control capabilities of man.
The space program's workhorse. Pilots will routinely fly into space, do research for the Gemini and Apollo programs, and fly back.
Over the course of 9 years and 199 flights, the X-15 laid the groundwork for every space exploration program that has followed.
I don't think there's ever been an experimental test program that has come close to providing as much information to the industry as the X-15.
NASA's Parasev explored the possibility of using flexible wings.
A potential recovery system for the Gemini spacecraft. It didn't work out quite the way we hoped it would.
Train ourselves in coming down to a body without atmosphere.
A program to develop the piloting techniques that were used during the final phase of the manned lunar landing was started at the Flight Research Center in 1964. To compensate for the gravitational and atmospheric differences between the Earth and the Moon, the LLRV was equipped with a gimbaled jet engine that produced enough thrust to counterbalance 5/6 of its weight, thereby simulating 1/6 gravity of the Moon.
It had more degrees of freedom than an octopus.
30 seconds forward.
When Mission Control advised me that I had 30 seconds of fuel remaining, I thought, no problem. It's just like the LLRV.
Scheduled to fly in 1965, the X-20 was a logical follow-on to the X-15 under the control of a pilot-astronaut, fully maneuverable and capable of orbital flight.
Though never completed, made significant contributions to the problems of orbital mechanics, inertial navigation, and re-entry dynamics.
Up to the present, manned spacecraft have been cone-shaped. They lack maneuverability. But as more and more men leave their work, easier, more flexible, less costly ways to let them return must be found.
If we were to eliminate the top half of the configuration and have more of a flat top on it as so, maintaining the expanding forebody on the aft end, then we would develop lift as shown due to the pressures acting on the bottom surface of the vehicle.
Lifting bodies are wingless vehicles that obtain aerodynamic lift from the shape of their bodies,
Capable both of high-speed re-entry and low-speed landing. The lifting body is reusable. Its initial cost could be spread over hundreds of flights.
speeds approaching Mach 2 and altitudes greater than 90,000 feet. The pilots stabilized and controlled the craft by using its fins and control surfaces.
With a lifting body, you could fly back to a chosen landing site without any motive thrust, just taking advantage of energy management.
Information obtained from flights of the YF-12 will be used to further the development and operation of the proposed space shuttle. NASA's reusable shuttle orbiter, part of a new, less expensive space transportation system.
With no air-breathing engines, will be flown to a powerless landing, like a glider.
Dryden Center undertook the first approach and landing tests of the space shuttle, here launching it from the back of a Boeing 747.
Okay, we are armed. 2 lights and orbiters go. 250. Houston is go for set. Have a great flight. Stand by. It wasn't too bad. Now. Okay, she's flying good.
During that series of flights, we were able to gain experience on the hydraulic and communications and electrical systems, the handling qualities of the shuttle. And we're able to make some minor adjustments to the flight control system in the landing phase of the program.
The test demonstrated that the shuttle has acceptable landing performance, another milestone in the Space Shuttle development program.
One of our F-15s was flight testing heat shield tiles for the space shuttle. We learned a great deal about thermal tiles and how to attach them for flight in the atmosphere.
Never before has a winged vehicle been launched like a rocket, orbited the Earth, returned through frictional heating and landed, still aerodynamically sound, to be launched again and again.
Dryden has been providing landing support. We maintain the visual landing aids, activate our control room, and provide radar coverage for the landing itself. We also assist on the convoy operation that is used to safety orbiter and help the crew to egress. This specially modified 747 is towed underneath the shuttle here in the mate-demate device, and the two are bolted together with 7 large bolts for its return to the Kennedy Space Center in Florida.
Jetstar test flies the microwave scanning beam landing system used by the space shuttle when it returns from orbit.
Do you want to look at the tiles, NASA One, or have you seen what you want? This is the heaviest concentration right here.
We concur. We're seeing some damage show up on tile number 2 and 3.
The initial test will involve orbiter landing gears. In the extreme test, we actually plan to go enough beyond the design conditions to cause failure of the brakes and actually blowing the tires. The unique feature of Pegasus is that rather than starting from sea level and launching vertically from a launch pad, we'll use this B-52 mothership to carry it to high altitude.
Today's initial launch of the Pegasus air-launched space booster marks the first time that a privately developed space launch vehicle has carried a satellite payload into orbit.
Able to fly from airport runways, ramjets, scramjets, and finally rocket propulsion directly into Earth orbit.
The rocket engine they are testing on the back of this exotic Mach 3 spy plane is part of the X-33, an experimental aircraft designers hope will lead to a replacement for the space shuttle.
NASA researchers are looking for alternate means to reach orbit. One possible solution currently on the table would use air-breathing scramjet technology.
This flight was a key milestone and a major step forward in producing boosters that may send large and vital payloads into space in a reliable, safe, and inexpensive manner.
The development of the space station has also created a need for a second kind of space vehicle, one that could bring astronauts back to Earth safely in the event of an emergency.
The shape provides a large amount of cross range relative to a capsule. Instead of pulling the trigger and going exactly where it's aimed, I can pull the trigger on a lifting body, and I have 700 miles to either side of that initial path that I can maneuver.
The X-38 is equipped with a parafoiler, a giant steerable parachute that allows it to fly to a pinpoint low-speed landing on simple, reliable skis.
We can't tell you all the activities that people will do in space, but we are certain the number of people and activities will increase greatly as the cost comes down and safety improves.
The next great American-led trillion-dollar enterprise, the commercial space enterprise.
And we think that the technology to support the commercial exploitation of space is an appropriate task for NASA in the years ahead.
There it is. Stand by for final recovery chute.
Pad abort number 1 crew module is here for mass properties testing.
We were tasked to install the instrumentation, all the instrumentation sensors, and the avionics systems to make this vehicle fly.
The abort flight test provides important data that is used to validate the safety predictions for the overall Orion spacecraft.
FPC jettison. Pilot deploy. Mains are out.
Some released.
We took our exact same code that's going to fly SLS and we put it on the F-18. And then we had the F-18 fly trajectories that matched what we would see with SLS.
We don't land successfully without this radar that y'all tested.
The radar has to take just the right altitude and velocity measurements at just the right time
or the rest of the landing sequence won't work.
If you're not sure of the atmosphere on Mars, this will compensate for those type of design errors.
And this is an idea to try and fly a small UAV on Mars, get some reconnaissance photos of potential landing sites.
The next step for the fiber optic sensing system is going to be to design a ruggedized system that will be able to survive the space application.
The Flight Opportunities Program purchases commercial suborbital reusable launch vehicle services to quickly fly technology payloads.
It's a wonderful example of how government and private business and academia can all work together very well.
We're supporting NASA's Flight Opportunities by testing different technologies here in the desert that will hopefully land on another planet one day.
You can do space tourism, you can do research education missions. NASA is supporting the commercial spaceflight industry